right, let's verify the identity. Cosine of 4t equals 8 cosine to the 4th t minus 8 cosine squared t plus 1. We always want to start on the side with the that's more complicated. And although there are many more terms on the right-hand side than the left-hand side definitely has the more complicated argument to it. And it's a lot easier to tear down an argument than it is to build one up. So we want to start on the left-hand side. Well, we're trying to get from an argument of 4t down to an argument of just t. All right, so sorry, hold on, guys. I just managed to like break the tip right off of my pen. Hold on, I gotta go grab a new one. Okay, so we're starting on the left-hand side, and we want to break down this cosine of 4t. Any suggestions on getting started? Any of our identities that handles an argument that is something times t? Well, if you look at your formula sheet, the only formulas that we have that has something times our angle t, x, theta, whatever, is our double angle formula. So we can take our left-hand side and rewrite that cosine of 4t as cosine of 2 times 2t. So this 2t here would be like our theta in our double angle formula. Now, cosine has 3 double angle formulas, so we need to decide which of those 3 we would want to use. And to help us make our determination, we want to look at the right side of our identity. Look at what we're trying to get to. Oh, which of those 3 double angle cosine identities do you think we're going to want to use? Well, the first one has cosine and sine. The second one has cosine only. And the third one has sine only. Looking at what we're trying to get to, which of those 3 do you think we'd want to use?
The cosine only one?
The cosine only one. So this will become 2 cosine squared of theta. But remember, 2t is theta for us, so this is going to be 2t minus 1. All right. I'm going to make a slight change in notation. Remember that cosine squared of 2t is the same as cosine of 2t squared. So I'm going to rewrite it that way. Now we're going to repeat what we just did. We still have an argument of 2t there that needs to be broke down into just t. We're going to use our double angle cosine formula to accomplish that. And we want to use the one that only contains cosine because that's all we have on the right side of our identity. So we're going to replace cosine of 2t with 2 cosine squared t minus 1. That's quantity is squared, and then we have our minus 1. And our theta this second time was just t, so that's how we ended up with just t with the second iteration of that double angle formula. Well, I'm happy that my argument's down to just t, but it certainly doesn't look like the right-hand side yet. Suggestions on what we could do?
Can you square it?
Yeah, notice that what we have inside here is a binomial squared. Because of the minus sign, we are going to have to write this twice and FOIL it out. I would definitely do the FOIL first and then distribute the 2 after that. 2 cosine t times 2 cosine t is going to give us 4 cosine squared t. I feel like we're missing something here. Hold on a second. Oh, yeah, so look at this. When I wrote this, I wrote it incorrectly. This is supposed to be 2 cosine squared in here. So I'm off. I'm missing squares. All right, so we're going to be 4 cosine to the 4th t minus 2 cosine squared t minus 2 cosine squared t plus 1. Next, we'll distribute that 2. We get 8 cosine to the 4th minus 4 cosine squared minus another 4 cosine squared plus 2 minus 1. And then we'll combine our like terms. It's going to give us 8 cosine to the 4th t minus 8 cosine squared t plus 1. And there's our right-hand side. Questions, anybody?
Where did the 2 minus, like what's highlighted in blue, where did that come from again?
All right, so the 2 came from me distributing the 2 to this one of the constants. And then the minus 1 is just what I have tacked on here at the end.
Okay.
Anybody else? All right. Let's try another one. Sine of x over 2 plus cosine of x over 2 quantity squared equals 1 plus sine. Left side's definitely our more complicated side. We're going to have to change our arguments from x over 2 to just x, so we'll be using half angle formulas. I also noticed that inside the parentheses, I have a binomial and it's being squared, so we would have to write that twice and multiply it out to get things simplified. If you take a look at our half angle formulas, they are all full of square roots. So you need to decide, do you want to put the formula in and make a bunch of square roots and then write it twice and multiply it out? Or do you want to multiply it out first and then plug in the square roots? I personally would opt for the latter. I would do the multiplication first because it's going to be easier when it's not full of square roots, and then plug this formula in after the fact. So starting with our left-hand side, I'm going to have to write this twice and multiply it out. You guys see this keep erasing on me? Stop it. All right, I'm gonna close OneNote and reopen it. Okay, let's try this again. All right, so multiplying this out, we're going to get sine squared of x over 2 plus sine of x over 2 times cosine of x over 2. And then we're going to get that again. Plus cosine squared of x over 2. We've got some like terms that we can combine. We also have, check this out, sine squared of x over 2 plus cosine squared of x over 2. Well, what do you know about sine squared plus cosine squared when the arguments are the same?
Equals 1.
They're equal to 1. So I can just substitute what I have highlighted there in blue. I can just put 1 in its place. And then I'll combine the other like terms, get 2 sine of x over 2 times cosine of x over 2. Now we're ready to plug in using our half angle formula. 1 plus 2 times the square root of 1 minus cosine x over 2 times the square root of 1 plus cosine x over 2. We'll multiply what's underneath the radicals. Remember, you multiply what's underneath together and leave it underneath.
Where are you getting the square roots at?
From my formula sheet. From your, just check out your half angle formulas. You can either look on the back cover of your book. I didn't get the opportunity to hand out the formula sheet before we dispersed. I don't, or maybe I did. Do you see them?
Yeah.
Okay.
So how do you know like when in the
When to use
like,
it?
yeah.
All right. So because it says sine of x over 2. So that's our half angle. And if we look at the right-hand side of the equation we're trying to verify here, the argument's just x and not x over 2. So I'm looking for the formula that gets rid of an argument of x over 2. And that's always a half angle formula. Did that answer your question, Jordan?
Yeah, I see it now.
All right, multiplying our two radicals together. Remember, you multiply what's underneath the radicals together and leave it underneath. I'm definitely running out of room, so I'm going to come way over here. All right, so multiplying that out, and I'm also going to break it up into the square root of the numerator over the square root of the denominator. So on top, we're going to have 1 plus cosine minus cosine squared. And then I got the square root of 4 on the bottom. Combining like terms in the numerator, we see that those cosines are going to cancel out. This is 1 plus 2 times the square root of 1 minus cosine squared. And then on the bottom, the square root of 4 is just 2. And that's nice because then we can simplify those 2's. All right, we're trying to get to sine, and I'm still at cosine. What do we know about 1 minus cosine squared?
Isn't it just sin squared?
It's sine squared, because remember our Pythagorean identity? If you subtract the cosine squared over, you get sine squared equals 1 minus cosine squared. And that's what we have, so we're just plugging sine squared in. That's going to be 1 plus square root of sine squared, and the square root of sine squared is just sine. So there we are, 1 plus sine gives us our right-hand side. What questions do you have on that? Okay, our last one. Here we have sine of x plus sine of y over sine of x minus sine of y equals tangent of x plus y over 2 times cotangent of x minus y over 2. Any suggestions? Suggestions on even which side to get started on? Oh, I see an argument of x plus y over 2 and x minus y over 2. Those are like kind of weird, but familiar at the same time. If you look at your formula sheet, or you can look at the back cover of your book there. If you look at all those formulas, are there any formulas that end up having x plus y over 2 or x minus y over 2 as the argument?
Is it the half angle formula again?
No, the half angle formula, because the argument doesn't turn into x plus y over 2 or x minus y over 2.
For the product to sum identity.
So close, we need the over 2 part. So it's the other one, the sum to product. If we take a look at our sum to product identities, we end up with those kind of weird looking arguments. And if you look on the left side of our identity, well, how nice. We have sums and differences over there. What we're going to do with this one is we are going to use a sum to product identity for both the numerator and the denominator. And then I think we're going to end up with sine over cosine of x plus y over 2 for the tangent, and then we're going to end up with cosine over sine for the cotangent. So let's try it out and see if that happens. Starting with our left-hand side. Using my sum to product formula for sine and addition, this becomes 2 sine of x plus y over 2 cosine of x minus y over 2. And then in the denominator, we're going to use our minus sum to product identity for sine. And this becomes 2 cosine of x plus y over 2 sine of x minus y over 2. The 2's are going to cancel out for us. We have sine of x plus y over 2 over cosine of x plus y over 2. That's going to result in tangent of x plus y over 2. And then we have cosine of x minus y over 2 over sine of x minus y over 2. Cosine over sine. That's going to be cotangent of x minus y over 2. And that's exactly what we have on our right-hand side. And that's it. That was a short one. So, we've seen a lot of different techniques throughout all of these identities. I've mentioned that I really recommend doing a large volume of these identities just because different algebra techniques pop in, different formulas have to be applied. So this is really one where you do want to do a bunch of problems. And you'll find they're not in my math lab because I do not care for the way that my math lab does it. So it's important that you get into the ebook in my math lab. Just go to the end of the section where they have a bunch of problems and pull a bunch of problems to do for these. Anybody, any questions about identities at all? Mitch, can you do that again? You broke up.
Will there be any of these on the take-home quiz?
I'm sure.
Okay, good.
And what I'm going to have to do for the exam, because the exam's going to be in my math lab, and I don't like the way that my math lab does identities, so I'm going to give you like a paper take-home part for the exam that has some identities on it, and have you submit that to the Dropbox as part of your exam.
When's the next take-home quiz due?
Let's see. April 8th. Which is, wow, that seems like a long time from now. Because I am almost done with this next unit material. That gives us all next week. Geez, I was going to go ahead and start the next section, but I better not with the way that I have everything paced out. So we are definitely going to have a test on Tuesday the 14th, for sure. That on Tuesday the 7th, I will do section 6.1, which is the last bit of material in this third unit, and then I'll start the next unit, unit 4, on that Thursday the 9th, and then we will definitely be having our test on Tuesday the 14th.
And how are we doing these tests now?
So the test is going to have to be in my math lab, just because, HAC's already announced that the buildings are staying closed through finals, so I'm even going to have to figure out an online final exam. Our online proctoring services aren't available, so they're going to have to be through my math lab. I think, I'm still thinking for sure if it's just going to be, here's the window, get the test done during normal class time, or more likely, I'll probably give like a 48-hour window where you guys can go in and take the test
Yeah, my
whatever is
manager
most convenient for you.
thing where she gives us like a whole day to do the test and just says get it done within the day.
Right, that's my plan. Because especially with the hiccup that we had with my math lab, I don't want anybody freaking out that they go in to do their test and then it's not working. So that is most likely what I'm going to do is a 24 to 48 hour window to get the test done.
What happens if my math lab like shuts down or stops working or
Well, then
logs us out while we're taking the test? Do we email you?
You should be able to log right back in to the test and finish it. If it kicks you out, now if there's a serious issue like there was last week, well then obviously I'll have to do something about that.
Okay.
But
I
I'm
just
gonna
wanted to
put
make sure what
positive,
would
I'm gonna
happen
put
if a
positive
technical
thoughts
issue
into the
happened.
universe that doesn't happen. See, what happened with my math lab is just, so my math lab has been the leading computer software for math for 20 years. Well, they have not updated the server that they have used in about a decade. So when everybody switched to, and it was on their to-do list for like 2020 was to update their server. I think they were going to do it over this summer. When everybody switched to remote instruction and everybody got on my math lab at the same time, their old server just crashed. And the reason it was down for like 2 days was because they had all their engineers frantically working and programmers and had to put everything on a brand new server that could handle this type of volume. So that's what happened. Yeah. So we should not have that problem again. I'm confident moving forward that we will not have that issue at all again. Anybody else? Any questions about anything or just material? Nobody came to office hours before class. If you guys have any questions now, I got like 40 minutes before my next class that I will be happy to field. Otherwise, you can just go and work on your My Math Lab and work on your take-home quiz, and I will see you on Tuesday.
Hey, Professor.
Yes.
I sent you email